So another thing we can take a look at is the density of gases. Of course, we're going to assume that these are ideal gases, which isn't true, but it's close enough to being true. And so while all ideal gases, their pressure, volume, temperature, all of that kind of thing is the same, and it doesn't matter what kind of gas you have, the density is different. The density does depend on the identity of the gas. So we have our density is equal to our mass over our volume. And then we have our ideal gas law, PV equals nRT. And what we notice is that we have volume in both of them, right? So one thing we could do is we could rearrange one equation and then substitute one equation into another. So for example, we could rearrange this equation to get V equals nRT over P. And then we could take this whole nRT over P and then plug it into this volume. When you do that, you'll get density is equal to mass times the pressure over nRT. And then if we think about what we have here, we have mass divided by moles. Well, that's equal to the molar mass, which is a property of compounds that's very useful. I'm going to abbreviate it as molar mass. Sometimes it's abbreviated as like a cursive M. I'm not very good with cursive, so I'm going to do double M. You can use different symbols. It's totally up to you. So then our equation becomes density is equal to the molar mass of the gas times its pressure over R times T. And we'll use this equation decently in word problems. So one example of the word problem is, what is the density of dinitrogen monoxide, which is laughing gas, at 62 degrees Celsius and 875 torr. The cool thing here is you don't have to have an amount of the gas, right? It's independent of that because it's density, that kind of thing. So pretty cool. Overall, it's just a plug and chug type of problem. Of course, we want to ensure that everything is in the right units. Remember that your gas constant R is 0.08201 liters atmospheres over moles Kelvin. And so all the other units need to be in liters atmospheres mole Kelvin. That way they all cancel out and talk with one another. For the molar mass, we're going to take a look at the molar mass of dinitrogen monoxide. If you Google that, you get 44.01 grams per mole. For the pressure, we're given 875 torr. That needs to be an atmosphere. So let's go ahead and quickly convert that over. For every 760 torr, there's 1 atmosphere. So that'll be 1.1513 atmospheres. And then finally, our temperature. That, of course, has to be in Kelvin. So we'll add 273.15, or just 273. You get 335 Kelvin. Plug that into there. If you think about the units, the atmospheres cancels out with atmospheres. The moles cancels out with the moles with the grams per moles. The Kelvin cancels out with the Kelvin. And then what we're left with is simply the grams from the molar mass, and then the liters from the gas constant. And that's perfect because density is mass over volume, and you have a unit of mass over a unit of volume. And hopefully I plug this in my calculator. I got 1.84 as the final answer. Again, these are kind of plug and chug type of problems, so be pretty decent at them. I don't have to necessarily ask for the density. I could ask for the molar mass or any of the other variables given the other variables.